you should have some kind of backup in our mind, like the priorities what you give, and based on that, um, you can adjust our time to spend on the each course. So it is not same for everyone. It is for different students have different kind of goals settings, like to go in which area they should go. Accordingly you should manage it. It's not all the time like you should be perfect in all the courses. It is I don't suggest that even. Like one cannot be perfect in everything, and even if you try to perfect everything, like you should decide why are you making it perfect everything for uh, making it good cause of your life. Like suppose you feel like there is a suppose some course X, I'm not mentioning any, for that is not same for everyone. You don't feel like there is something good in it for your future perspective, for your goals perspective. So you just take it as a kind of like a low level interaction with that course, so that you will get through it and you will know what is what inside of the things. But you can focus the time on other course, so that where it actually gives the big difference in our uh, give me a minute. Sorry, like so the so even my experiences is like, I do not consider some of the courses uh, for going into the deep. Even there are two things again. There are two personal aspects here. Course may be interest, or you may fall in love with that, and you may feels like so excited to do the things. But you should think of it whether the excitement of the course is making any sense for the future aspects. Because I did a lot of mistakes by doing such things, like I entered some way in the mathematical biology, and I spent a lot of time on it. Of course I learned a lot of things from that, but I didn't use it later. I don't regret of this, but I could have spent that time of around 6 to 8 months, I could say, mathematical biology. Could have spent on the some other areas. I could justify that I can take up further later. But now, if I think of that, in now this point, um, does it worth that taking that course mathematical biology? That time I have excited to learn the things, because I have eager to seep into the several directions and dimensions to explore what I think of it later. Once that the peak of excitement comes down, um, again we'll look for another peak of excitement. So I should say, there must be some balance between the interest and keeping that into the aspect of what you wanted really be in the line of productive. So otherwise, what will happen? You will travel one with other and one with other. You will have a lot of trades with different subjects. But if a point comes to fix on one thing, and you really struggle, like in which way you should take a path, because one thing is sure, that after a certain point of time, you should have to stick with one. That is sure. That is sure. Now and that converging point should be in a smooth way, not like a hard converging. I mean, like the point where you decide to work on, like trying out everything till next another 5 to 7 years or 8 years is okay. You reach 27, 28, or before 30, I would say, there is no issue. But after a certain point of time, it definitely one cannot do all the things. The time is the one thing parameter which really hurts, really hurts. So that is the point. Like when you are focusing different subjects now, yeah, do it in a good way, but always keep in your back of your mind that in the career aspect too, or the converging point of aspect too. So the convergence, I mean, what I mean by convergence means you should land on some ground at a point of time that may be ahead of time right now. You may not see that point exactly at this moment. So that is why everybody tries different and dimensions to learn it out. So always you, even if you don't look at the what is the converging point, at least you should circle it out. These are the potential points. One of the things I may pick it up in the future. That may be anything. So around 4 to 5 fields or 4 to 5 converging points you should land up after certain point of time. Now you should to think of it spending time on any course whether is that relevant to that converging point. Don't go odd out of completely like one with different subjects. But in the serious way, you can have always have a rough surface, a glide of accumulating the subject. It's okay, but in the serious way of delving into the subject is a kind of like you're damaging the your time, the value of your learning. It is so important that time value of learning. So learning is important as well as the value of the time you are spending on it, on which you are learning, is also a real biggest parameter in developing your learning curve. So um, why I'm saying all these things, you don't worry about the subjects which you are not performing well. You focus on the outcomes of learning. I believe strongly. This is my personal opinion. I am not making any generalized thinking or generalized perspective of learning models or learn. I mean, human learning mechanism. How students learn, how not only meaning of students, every human, irrespective of uh, the education or those who are in the academic or non-academic, whosoever. So the learning strategies are changing very rapidly. The way 10 years or 20 years before, um, we learn the content, we learn the whatever subject, irrespective of the domains and fields. Then now how are we learning the subjects are completely different, and maybe next 10, 15 years it will be completely different. So this you should think of it like you should not fall in the trap of the same learning strategies what conventionally the system has developed, like the system we have built for long years to through the educational institutions or no, so whatsoever, the exam setting or all these things, whether um, are they like are they really a need the way it was developed, the institutions, the learning institutions, the schools, colleges, or labs or research institutes, whatever, uh, whether they really need at this moment of time, or That is so important, like, because it is the tremendous increase of learning abilities, individual learning. Nobody is looking for like somebody has to teach me, and so that I will learn, so that if I get marks then only I will so there is no judgment of subjects at this moment. Like, you see, I strongly believe like 10 years before the certificates have values. Nowadays I don't think that the degrees or the graduations or marks, still there's a following, but majorly it is decaying, I could say. I'm not saying the blatant statement like and it's completely eradicated, but it is the day by day or year by year, it is decaying the way it was earlier. So now you see, like, let me give an example. You go for an suppose let's at our home, you ask for a electrician for some repair work, or a carpenter or a painter, or for your renovations or something else. Do you check whether he has uh, whether he has any degree, or whether he has kind of like how he mastered and who learned how he learned this work? We don't check it. We just get the intuition that somebody by mouth, or by seeing his past experience, or by seeing his past works, he is a good expert, good skilled person, so let hire him for this work. So we don't see anything else. We don't look at it. The thing, same thing slowly comes to this pattern as well, to the educational experts. Like, suppose you come out of there, you explore yourself as I am so and so, I am a this expert of this subject. And so the companies also changing policies right now slowly. It's a very beginning phase, very very beginning. It is a new trend, or I could say it is a beginning of a new era. uh, they divide the work and look for the expert and give it to that, and get the work done and just finish that. That's it. Like, it won't be like a kind of uh, a kind of like having the people inside complete all the time and doing it. So you will be having free of your own time. Yeah, so you are having hold of your life with you. So this will start by the maybe next few years of I could say 10 to 15 years. I can guess it, because this is changing the learning systems. So you don't need of a degree, especially to have a complete skill on a particular object or particular objective of your skill set. So you, when you come out of your graduation, make sure that you have enough skill with you rather than the information crammed in your mind. That is the objective. If you cram lot of subjective information, and you know a lot of things, but information of this from the textbooks, from the materials you read, from the whatever ways you will follow to learn, the whatever resources you use it. These are all abstract information in your mind, but they don't provide you a uh, skill level, fine-tuned skill level, what I can say, to do a particular task. So you convert the knowledge, or convert the learning, whatever, convert that into a skill way. If you don't convert the transition skill way, that is the one major lacking in the graduations I see from long years, that people having subject very good, and people having good knowledge on the subject, but are they really transforming that knowledge into a skill form? So that differs, the who have the knowledge and who have the skill. So that is a fundamental thing. So whenever you learn something, you don't learn it just like it is a information. So now you can think of it like uh, earlier, let's say 5 years before, programming is so important to the companies to develop their applications. But now, programmers slowly they are making clear of programming people. They are not making it any new hirings or because now the intelligence tools are making something like whether you know programming or you don't know the programming. If you take two candidates, if you one who has the expert in the high level skill of programming, one who doesn't know the programming, but he knows a little bit of how the program works and how the basic things, but programming skill is not reached up to a level like he can code on his own. But now these two people are same. These two people are same in this era because it doesn't have any difference. So you just need to have an idea to organize the code, not to implement, because the tools are developing the algorithms, and now these two have same capacity as because of this one. No, learning skill of programming is an advantage when you choose a path beyond a point of develop learning models. In the aspect of this one, I am talking in the computer science. But for every field it has its own course of advancement that need to be take up. Otherwise, you will be staying at the place where the knowledge, the skill you have with and skill you a person who doesn't have that skill will become equal. So the tools are making such a way like feeling uncomfortable or feeling sometimes injustice to spending a lot of time on this one. Like that is frustrating sometimes, but that need to be overcome. So my end of my story or whatever you say, this you develop the skill. That is also the skill should be a kind of like, you should deliver something. Otherwise, a list of courses, I think by the end of the BTech you will be having around 30 to 40 courses, if it is correct. um, so you look at all the list of courses after a 5 years of your BTech, then you don't see anything that you are that time you are currently have any touch with anything. But why are you learning all these things? Because that is how we build our systems and to have the things. Now this will change. I think policies will change up in next few decades, on I could say 2 to 3 decades. Like there is no need for personally. I have gut feeling. Even I also come from the way you have from the same systems also. But in this era of rapid change of learning systems, one doesn't need a no question. I myself question I sometimes like, does to learn a particular skill, does really 4 to 6 years, 4 years of BTech or 2 years of masters is really required? That is question of me in this age, in this era. This need to be, it takes time, of course, not only just in India, everywhere in the world. Need no policies will change in the not everywhere in the world, so that the educational reforms may come up, so that to develop a skill, it doesn't need of a spending this much of time to do a particular to reach up a particular task level, and get the look at the objective of in the market, and what tasks need to be done, and what are the skill set is required, and get the skill sets breakdown not as a courses, as a skill sets. Now you can see like you are learning something. If I ask you something, what are you doing? You are studying BTech. What you do in the BTech? You learn, go through the courses, and what courses will give you? Courses give you the information about the course, the stream, the domain, the knowledge, and now that will change. How it will change? What are you doing? The question comes like, I am learning. What are you learning? You're learning a skill. How what are all those things? These are a specific objective. Like you don't diversify your mind into various other things. At the end you can't do anything. So at this point of juncture, what you should do is, you should do something called converting your knowledge into skills, I could say that. So look at, otherwise, if you don't turn your knowledge into the skills, um, at a point of time it pressurizes you to survive in the market. At any point of time it will come, once you finish your once you start your career. So that perception you should have from your BTech level. So have skill sets rather than just courses. Courses will give you the paths only, but the skills comes on your own. So what I am teaching this neural networks, if I take a for example, now you should think of it how it can become a useful skill set. What you are learning is not a skill. What you are writing exam on a neural network and mid-sem, and what I am teaching, it is not a skill. It is the knowledge transformation, what I have explored and what I have progressed or thought process, that is being feeding into your mind, so that this is the mechanics, or this is the machinery, this is the process, thought process, building scenarios, all these things, how it is built. I am just explaining the way I have learned it, and the way I have accumulated the knowledge and the experience of the skill, whatever I have, that I am transferring it to you. Now, what I mean by converting that knowledge into the skill form is, now you look at the tasks, whatever happening outside in the market, and take a particular real life task and apply this knowledge, how this knowledge or tasks are utilized there, and you keep your hands on experience, and so that you relate this informative knowledge is really making a real task outside world. So the real world, the out of the textbook, out of the knowledge domain. So that the way, the eye you have in our back of your mind every time when you learn it, the way you can apply in the tasks, then you have mastering something called knowledge transforming into the skill sets. Unless you don't do it, I'm just given an example, you should this one, and that depends you, like you are a web developer, do the same. If you are a something, you are seeking for something else in the future, in the direction, that knowledge transformation into the skill set is very essential. Okay, that's stop it. Now tell me, what are you up to, your framing of your skills. Do you Are you getting enough time to develop on your own, or mm, spending time on looking at what market really needs from you? It is, if you don't do this one, you are completely detached, and suddenly you see this, and then you run for it. That's arts. Okay, you can talk now if you have.
Okay, sir. Thank you, sir, for this
Yeah.
suggestion. And sir, I felt, sir, my time, lots of time have gone for this course curriculum. Sir, few subjects I can relate, so like neural networks and uh, in last semester we have studied non-linear optimization. These subjects I can relate like how I can use in skills like if I making any kind of model for solving any kind of problems, then I can use these concepts. For other subjects, till now I can't relate with like that skill set. Like
Yeah,
I am
you
studying,
that's what I'm saying. You don't need
yes,
to relate every course with everything. Then you know
yes,
you have to fix your what is your kind of platform you land up after a certain time. Based on that, what you spend time on this one is important. Suppose abstract algebra last time I taught you that you may not never use in our life, but you
yes, yes,
have some idea. But so that kind of courses are in the, you just take a light up spending time on that complete. You are maybe there are excitements and all like, but yes, I don't suggest that spending time on it. Spending time is different for different people. Like somebody in our class may have the go in the line of research level like abstract mathematics or masters in the mathematics, then for them it is so important, and it is definitely it is worth for them. So it is individual decision, individual choice of spending time, and that is our measure, that is in our control. So
yes, sir,
yeah.
yes,
So that is why I am not much worry about, like, the courses what you do, and courses for how much you are spending. But the end of the day, you know what is happening outside of your classroom, outside of your institute, outside of the world. Are you ready to face? Are you enough capacity do you build in our educational time, like the mindset, so that it is so rigid and fluid, so that you can able to adapt the situations. These are so important. So, irrespective of what happened, like, you should not strict ourselves. Like, I am like this. I this one. I know this one. Like, the subject in the matter only. Okay, you should have a flexibility of your changing. The course of life, adaptability with the market or with the outside the world. This is all we change our world. Even if you think of it like, I can't adapt the world because it is advancing very rapid, or so actually we are, the world is not advancing, we are making the world advance. So we are pushing the world into all the time, a different state of nature. That is why the advancement comes into this level. So we are part of it. Yeah, so uh, keep keep your, the mind so excited, my, all the time. Keep an eye everything whatever you comes in your way. Understand, adapt. uh, that's it. The flexibility is the only one thing which makes one's unique. Okay, that's so this is our time. Like, my condition were very different, and I feel sometimes I could have been like the course what you are taking in the mathematics and btech, like in the graduation time, maths and computing. This was my deadly time point. I did my masters in the computers, and I couldn't understand. I mean, I could not say I couldn't understand. I, after my finishing my masters in the computers, I feel so dry. Like, there is always a dead ends in any subject I take in the mathematics, like, I'm sorry, in the computers, in the graph theory, or data structures or databases. Um, Always I have an endpoints where I couldn't able to ground them up very clearly. So all these endpoints forces me to do mathematics actually. So that is why I took a turn computers to mathematics. Usually it goes like people do mathematics and go to the computers. I come back from the computers to mathematics to know the bridge, how the syllabus are built, or I mean the subjects, whatever, built from the mathematics. Then once I landed on the mathematics gives me a kind of a big platform where I have tremendously, I have seen the world in a different way. So uh, if I don't take that one, I maybe, I don't know, I cannot imagine myself who am I right now. That is, I don't know. Even after my masters in the computers, I had the opportunities to go in the computers in a good way, but I decided to do the mathematics to fix what where I struggled in the computer science, where it is not allowing me to go into the deeper insights. Like if you take database management systems, that was my one of the biggest hurdle during those times. Like why this relational database management, why that is happening, why, how these are built, how the, what is the structure behind them. Then after coming to the mathematics only, it gives me a complete crack of all those things. It is the full of subject of predicate calculus, which opens a lot of set theoretic, abstract algebra, all those things, which makes me clear once I landed with this one. So now, uh, sometimes I feel like you are having a blended concepts of mathematics as well as this computer, so that you can closely relate all the things. Like those who are doing only computer science or data science, they do not understand what mathematics in your, they may have a neural networks, they may have a data science people, they may have a something, this one, but mathematics is the key behind of anything. Now, uh, having courses of mathematics will actually is setting your computer's career or computer's line, is a kind of, clearing the paths, clearing the uncertainties in the computers. So I don't think you will be. I think I think you can able to see the maths and computers so closely. Am I? Or you are seeing still the both are different?
No, sir. From your teaching experience, I can say before that, sir, I cannot say any there is a related relation between computers and mathematics. After that, sir, I can relate or like if I am writing any kind of code, then I can relate that code comes from mathematical logic, sir.
Mhm. Yeah, not just the coding, anything. Like, don't
Yes,
think
sir.
of the computer science courses are the independent. They are completely built on the lot of other logics and mathematical basis only. Whatever you take it. So that ground is actually gives you a feel of, you know something else, so that you can perform your skills in the next level. So the understanding the ground level things are much more important. Like you may apply, if you take a computer program and you can call a library and you can do it lot of tasks in the neural networks in the perspective you talk of it, like optimizers, or what do you call, like several optimizers, stochastic gradients or Adam gradients, or there are a lot of other bunch of things were there. So now, even if you don't know some of them, you can go back. What is the math behind it? And you can look at them. The math, what is behind it is you already learned it, but you just need to know how it is applied to here. So the connection you need to just establish. So optimization techniques will give you that. The basic optimization theory, which makes you that set of platform to understand those models, how they build the algorithms into the machine learning systems. So now you have at least, you don't know what they are exactly, but you have a confidence to go back and look at them and to make them understand, to make them open a lot of other things. So that is what, like, maths and computers are a good deadly combined subjects. I feel so good like this course who are in this, like especially rather than just for those who are having the computers. So you can have a much advanced if you compare with the only just having computers. Of course, even many computers students do parallelly the mathematics to understand the things that by self exploratory, but you don't need to struggle too much on it. Okay, we'll start today what where we are and what we are doing. Do we see my screen? Do you see my screen? I just shared it.
Yes, sir.
Okay. Okay, where are we? Mm, okay, fine. We discussing maths behind this. Okay, the error term and the differentiation. Okay, this is a kind of like we come up with some kind of functions of the weights. So let's say there are n weights, and this is, I think I have just mentioned it as a phi. I just keep maintain the same phi. So this is a function of the expression in the loss function. That's what like what we are neural network is basically comes out of outcomes, and we are bringing them into a loss function comparing the supervised learning. So that's we have discussed so
Sir,
far. Yeah, yeah,
am I audible?
yeah. Go ahead.
Sir, can you give me an example of where you have converted that knowledge into skill?
On that, like the expert of, I could say one point. The my knowledge on the computer science, the programming skills especially, I could say, and the second one, the understanding the world through lens of mathematics. These two makes me look at the problems in the world, uh, especially my line of world is actually a research line. Almost I have been in the last 8 to 9 years, I could say. I'm in the line of research. So what I do in the research, I look at the problems whereby what potential problems need to be solved, what potential problems need to be solved in the world which is not yet been solved. So um, the list of problems, when I see them, so the journey which takes to solve them, which is required, the transformation of knowledge into the skill. Like for example, I could say uh, at the moment at the moment, what's my work in the research is, there are systems already developed in the majorly in the German automobile industry or companies or whatever. They have they lot of problems. They have coded their problems into a problem statements, like this is the problem, this is the potential problem we are facing in the manufacturing, this is the problem we are facing in kind of industry which is expecting from solution from solution manufacturers, whoever, researchers or whoever. So for example, if I take a problem, I will go a lot of problems I have been through. For example, a simple problem I will tell you, the problem which uh, this is may not be a problem for many of our domain of the world, but in the industry, for every small thing is a problem to overcome. There is an industry. Germany is famous for beers. The here almost every people, Germans local, they drink beer regularly. As the consumption is very high. So the companies are asking some problem in their system. Like when they are serving the beer to their customers from the dispensary machine, when they put the bar of what do you call it, mug under the dispensary, some of them are unsatisfied because of the dispensary system is producing a lot of foam, so that it is not filling the mug completely with the beer, so it is no, one third is getting wasted by filling the foam on it. So the problem which I take up, or which I looked into it very deep, that I need to develop uh, a model so that the dispensary works very fine, so that which takes the input from the fluid consistency, the fluid chemical nature, so that what kind of setting automatically it should do inside the dispensary, so that it won't fill lot of foam in it. So I need to optimize there. So this is the problem. This is the problem of a company gave to our research industry to solve this one. So they pay. You can't imagine how many $1 million they spent on this problem solution, looking for this solution of this problem for long years. So these problems are so crazy sometimes like this. Are the serious problems also. I'm just to make you understand in a simple terms, like not to complicate the problems. I'm just picked up this. So so the company wanted precise model to do this one. So now to solve this problem, what I have, I don't have anything in my mind. There are it requires the amount of knowledge of the mechanics of the dispensary system and the computer program, and we need to build how that could be possible in a simulatory sense. Like I need to develop first before going into the machinery. We need to develop a precise machinery in the virtual format, and need to develop a model. That model should work in the virtually with satisfying all the flow properties and flow of that particular fluid, in this case the beer. So what now, to solve this problem, if I sit on top of it, like lot of things will come up. What the why the foam is forming, the chemistry, and how it is interacting with the fluid walls, the container walls, how the pressure is, how much pressure, or how the pressure is influencing the dispensary mechanics of the system. So each one of the component, if we break it down, it gives a different domain knowledge. It requires a different domain knowledge. Now that knowledge of expertise being and putting into this solution process of this, whatever hurdles you face in this process, that you are experimenting your knowledge with the real problem, experimenting your knowledge into the real problem which is need to be solved and delivered, and it should work in the real ground to the customers at the end, so that they satisfy and the company earns from them by having a lot of people and attracting customers into their wherever they put it. So it is in the researcher's hand to solve this problem. And now what I have the knowledge only. I don't know the solution of it one, solution of the problem. So uh, the knowledge, now what I have to do, I have to connect all the different disciplines of the knowledge into the solution process. So during that time, it cannot be a ready-made solution to do this one. Okay, do this one, do this one, do this one, so that you will get a solution. No, there is no such. So we need to spend time, at least maybe 1 year or 2 years, not just a single people, or maybe a group of 10 to 15 people sitting together and breaking the work into different people, different parts. One with the design, one with the working on the chemistry, one with on the simulation settings, one with on the programming, one with on the design, developing the model. So we discuss all together and ideas framed up. So in this process, how the knowledge is becoming into the solution process, it is becoming hand skilled. So that now any problem which is matching or closely matching or with this experience, once you solve this one, let us by trialing a lot of experimentation and a lot of dynamics and looking at how it is possible and optimizing all the parameters involved in it, and ahead of the objective of solving that problem, definitely you have a handful of skill. It is not a knowledge now. The solution process is not a knowledge now. It is a skill in our hand, so that whenever you see the such scenarios or relative scenarios, you can immediately apply and solve it. You the parallel problem also, there is a parallel problem now. That is not with our industry and my friend's industry. It is in the US, that is called agro something. They do agriculture products, and um, they spray systems, the pesticide spray systems have also have that nozzle. They have a problem of something called droplets. Like they say 40% of the pesticides on the crop is get wasted because of aeration. That is, droplets are too light, so that they flow with the air when they are spraying on the plant or spraying on the crop. And if they make it little adjustment, the droplets are too heavy and they fall on the ground and they are not sticking with the crop. You understand this one? So now we need to again optimize the nozzle, optimize the that spray system, where where the optimal amount of the pesticide reside on the crop. It should not, it is not going away with the air, and it is not falling on the ground. So that how can we we cannot eliminate completely, but what is the optimal point, that we can fix it up. Now if these two problems are similar kind, mechanics are not exactly similar, but kind of this who solves the one problem and other problem would be easy, 50% at least I could say. Because definitely it is again a fluid interaction with the mechanics, and the parameters are different for different situations. Now it is a skill, it is no more a knowledge. So it is a knowledge. If you textbook, if I write a textbook on it, if we write a textbook on it, like how I solved this problem and how the process goes, and if you read this textbook from the this thesis or something, then it is a knowledge you gained it, and one who are doing this task, they are gaining the skill. And one, suppose if you apply the same whatever documented information which is you studied from the document, and if you apply somewhere the same thing whichever you see encountered, and you solved that problem, that knowledge transformed into the skill set. Okay, so now what you are doing, you are reading it from the already coded information. You are taking into your brains as it is a knowledge. Of course, this knowledge is compulsory, essential. Unless you don't put it in the real life problem solving, it won't convert into the skill set. Okay, that is called experience. You read books, that is not called as an experience. You suppose if you read the books for next 40, 50 years, that is just you are accumulating the information from the experiences by the others, other expert skills you are accumulated. That is not a same as the same. So that is what the difference, the skill and knowledge. I hope you understand with this elaborative explanation.
Yes, correct. Thank you.
Yeah, yeah, that's the thing. So if I read, of course, I'm not discouraging the reading books or anything. That is compulsory to adopt new skill sets. The accumulating the knowledge is the first step to develop skill or to make it real life expertise on a particular task. It is compulsory. If I don't have knowledge on any of the domains of which I specified for a problem, I can't enter into the problem even. First of all, forget about the solution and all. Even a problem would be a nightmare. So yeah, okay. Coming to our neural networks, whatever we are discussing here, the fee of functions of this one, the loss function, as you can see here, the loss is made up of like uh, this is a function of the targets and outcomes. I could say, right, this one. The targets is the expect the outcome of the neural network, and output is, oh no, the target is the original answer, and O is the output of the neural network. We have kind of relation that is we have given here above, and this is a loss function. There are a lot of loss functions you can. Now I would like to ask you a question, like the shape of this loss function is is based on what? Is the weights or data or yeah, I could say only these two. Yeah, or both. The shape of the loss function. Yeah.
Both, both, sir.
Okay. Mm, okay. Both are not like we'll see. Like how data is contributing to decides the shape. How weight? Suppose. Let me do one thing. Uh, Suppose if you have a problem and there you have the uh, data. Let's take two different data, data 1 and data 2, and you have the same weights you maintained on the same neural network, and do you see the same shape or different shape? Here I mean the shape is not exactly the shape. I mean I could say the topology, like you see some kind of parabola, or maybe some kind of this structure in the loss function in the higher dimensions, of course. And who is deciding majorly? The weights is actually the variables which are keeping in the output. This one, right? This one. So the data is doing something. Data is establishing this target and output relation. So who has a lot no, full hand on it, whether weights or data? That The weights are deciding the dimensions, like in which dimensions it is the loss surface is sitting. So the loss surface, uh, the structure of the loss surface, or structure, not the exact shape, the structure means that is how the how it is expanded throughout all the dimensions, and how many local minimals are there, how rough it is. Who is deciding that? Think carefully. It is so important to understand much better in the the loss surface. What weights are doing actually?
The weights are doing like it tells the dimension of the loss function as you told. Like so, you have
Yeah,
explained one example of linear regression, taking two
yeah, yeah.
components
Hmm.
A and B, then loss
Yes, yeah,
function
yeah, yeah.
depends.
That is good thing. Yeah, linear
Yeah,
regression. Okay, let me
yeah.
start with that. Like you have this one, and you have a loss function, this one, and so you will be having the weights here. Let's say two weights A and B, and the weights are for different weights, and you have different point of loss here. That's what you can think of it. You can say a bowl in this case. In the regression case, only you will get a bowl, where you don't get bowl. uh, so now these weights are determining this point, kind of structuring this shape. But if data is different, do the same bowl will come up?
No, sir, because using the data we update our weights, sir. If the
Okay,
data,
okay. We are not okay. Updating weights are something different. Like updating difference means we are checking for a particular weight combination. We are
yes,
now
sir.
it is a weight. This each point is a weight vector, and for every weight vector you have different error loss. And now my question is, even whatever data you have, no matter, but this domain is same, right? This domain is same, and this domain actually gives you the weights actually involved in the loss function, but involved in the loss function to determine what is the loss at different weight vector. Now my question is about this one is a shape, right? This is a one particular shape, and now if I have who is deciding this shape? Who is deciding? The weights are controlling, and who is deciding the shape? You should have a clear distinction. What data and what
That
is weights?
data sets, sir, because
Yeah,
uh, if data like if my data sets follow some linear relationship,
yeah, exactly.
yeah, then
So
in that case,
data is the one which is making you cause of this one. Weights are actually playing to design that one, but data is actually describing what should be it is, whether the nature of the data, the nature of whether the relations between how the data is related. That is describing whether it is a flat or whether it is a skewed, whether it is a symmetric. That is given by the data. The shape, the structure is provided by the data. The what weights are doing? Weights are constructing that shape. Weights are not providing, the weights are not the building blocks of the shape. Weights are constructing the shape, but the shape is given by the data. You clear it? It is not the just what
yes,
I'm saying.
sir,
You should feel it. You
yes,
should
sir.
feel that. Okay, this is yeah. So the data relationships, the what kind of pattern it is sitting inside the data is the one which is the shape it is reflecting outside through the parameters weights. Okay. Now, today I think we have not enough time to go with this explanation. Maybe I will start little. maybe next class, further continuation of this backward process. I don't want to stop it in between or maybe something. Okay, before going to the, I need to touch the some point like how this one is being utilized inside our training procedure, and how the weights are tweaked out so that they converge to a point, and those are the best optimal weights to determine the relationship between the inputs and outputs, and how the partial derivatives are crucially playing the role of the weight conversion. So there is something called back propagation. That back propagation means like you have a neural network. So far you pass them inputs here from the input layer, and you have some output layer, so it's a fully connected. Then what you do, finally you end up with errors. These errors need to be make it low, and from the errors we make it something like a loss function by accumulating all the errors we make the loss. This loss is describing this loss is described by the weight sitting on these uh, what we call edges, sitting on the edges. So if you change the each weight, it there is a change in the loss, because this loss is made by these all these weights, w and let's say n weights. And now uh, if you have a function f of x comma y, and or simply a single f of x, let's if you take this one, let's say this is f of x, and this is a single weight is describing the f of x, or the single x is describing the f of x. Now you can think of like what x you should change around a point, so that it is behaving with the f of x plus delta x, or with the f of x minus delta x. You should know whether you should move this side or you should move this side, so that where you stand based on every f. So now the same thing, you think of it, this is a function, this is a function. You should think of this is a function of which kind. It is a sigma net function, one of the sigma net function. Now uh, what change you make it in the W2, and sorry, what change you make it in the W2, let's say here, and so that this L will take effect. So what change in the particular WA, so that this loss will affect. That measurement comes from the differentiation calculus. That is how I wrote here, like the change in the loss function with respect to a particular weight is this one. And now how do we differentiate this one? Oh, I think I have gave it as an exercise to do this differentiation. Have you done this differentiation? To try this differentiation, it is easy. You can do it, and next time when I come to the class, that time I will explain in a, and how I think we have converted this into the matrix language, of course. Yeah, this forward process, we have converted this into the matrix language from here to here. That complete function, if you supply to x, you will get the outcome like this, I think. So the sigma net function being translated into the matrix language. So now in a reverse way, what we do, this one also we convert into the matrix language. So the loss. So the changes in the weights, what changes in the weights should take up such that the loss gets the minimizes. Loss gets minimized due to gradient descent. We take up into the consideration that process also we can convert into the matrix language so easily, that we will see. And that before that, you should know how to differentiate this one with respect to that differentiation. I will give a few hints. You can think like we are differentiating with respect to wij, but there is no wij directly here. So where is wij sitting, here or here, which term? Decay or
In
okay?
O in OK, sir.
In
Okay.
okay it is sitting, its output is a combination of all these things. So now okay is sitting inside wij. Now when you differentiate, what do? You have to do the chain rule, because okay is a function of again wij. So differentiation okay won't get zero. It is a kind of like again okay comes into the place, that okay is a form of again wij. Then from that, what you do? How do you look at this expression? And for every point, how do you think of it? For every wij, it is just a single parameter wij, but you have such an on it. So, how do you make the changes into that, so that your loss, you can think of the entire loss in terms of all the weights, not just the one particular weight.
Sir, can we
Yeah.
use like OK as a matrix form and let's say TK is our actual Y and OK as a matrix form like Y cap, and like we have defined our sigma nets in matrix form.
Yeah.
Then
Yeah.
that,
Yeah.
that matrix form, like
Mm,
let's take an example like if beta is the matrix of all the weights,
mm,
then we
mm,
can differentiate that loss function generally
mm,
with respect to beta and equal
mm,
to put the zero like whatever
mm.
concept we will use. Then
Yeah.
from that we can calculate our beta. Like sir,
Mm.
how we will get our normal equation for linear regression, sir? Same
Yes,
way.
yes, yeah, got it. I understood. Like, yeah, you try with the your idea, and
Yes,
you
sir.
see how can we translate that into the. It is a
Okay,
kind of
sir.
like, yeah, algebraic. Here there is no hard and fast mathematics. Here only kind of like you need to apply how well you can able to manipulate algebra to bring it down to a useful form. That's the only thing. We can't give much meaning here. Only we have to apply basic rules of mathematics to bring it down to. But we should not lose a kind of, in the process. We should not truncate or avoid a major things which are dominant play, so that otherwise our loss will doesn't have any make sense. The losses we should not apply. Yeah. Okay. Today, now, okay, you try that one. And how can you differentiate this one? And you establish the your trials in the next class, so that from that I will begin and we will go ahead. Okay.
Okay, sir.
Yeah. Now I will come and tell something which is I haven't come across so far in the neural network, and let me begin with something called a single neuron. Okay, I don't talk it as a neuron right now. Let me take a real line. Let me take a real line, and you have uh, just one dimensional real line. You have an experiment or measuring of some object. You have some weights or height, whatever the feature you see. You have not a one particular object. You have I can put it this way. You have two objects, two types of object, not two objects, two types of objects, two types. One is made with one material one, and another one is um, material two. So material one and material two have different weights. Now, one, you don't know which one is which material. You have, let's say, 10 objects with you of both kind. You don't know which one is which material, but they all look same. But you can differ only by their weights. Let us assume that, because of their material properties have different. One is, maybe you can think of stainless steel, and another one is polycarbonate, so that the weight difference would be great different. So you have 10 objects in front of you, and you can't differentiate. They look same, the colored same, and now if you collect data of this one, of their weights, then you plot them in a real line. Let's say uh, three of the four of the objects comes like this, and five of the objects comes like this, or six of the objects comes like this. Okay, the the way these dots are representing their weights. Now, what can you say about this data? So now suppose if I give some other new material, let's say 11th item, you don't know, it looks same. Now, to say which one, whether it is a come by the material one or it is come by the material two, how do you decide? How do you decide? You have 11th object right now in your hand, and
Like
you know already this one, already there are 10 objects, you have already coded their weights, and now you have a 11th item which is also looks same. Now you need to figure out whether it is belongs to material 1 or material 2. How do you use this data to uh, bring into which one it is? Let's say this
sir,
one is material 1 and this one is material 2. Yeah.
sir, we can do one thing. First, fix the 11th object on the real numbers. Then try to take the distance like from M2 materials and M1 materials. Like we can use here the KNN concepts, sir. Like
You don't need to apply any KNN and all. Like just simply find the weight of this one and put it there. Look at it. So let's say if it is close to the M1 points, and there are this one is M2 points. Then if 11th object is look at it whether 11th object is coming somewhere in the here or here, any group. Then you don't need to think of it. You need a baseline here, a particular a particular line here. I could say if it is beyond this point, you can say that compoundly it is a material two. If it is below this one, you can say material one. Now you have a lot of decisions on this base point. Which one you should choose, right? So here the
yes,
data
sir.
is so clear. Here the data is so clean, and they are completely distinct due to a property of weight and completely heterogeneous materials. One is stainless steel or polycarbonate. So they definitely the weight is putting something in a distinct classes so that you can separate it by a particular parameter, so that if it is beyond that weight then definitely it is material 2, if it is below this weight then definitely it is a material 1. So sometimes you can feel this judgment where the people who fake some materials by taking that object into hand, they can say okay this is not a original one, this is a duplicate one. Why, how do they say? Based on the senses, the features identified by experience of original materials. So this is not maintaining correlated with at least the close to the weight of this one or any other feature whatever they experienced with. So we do naturally by sensing the features, by weight, by color, or by and the looks, whatever features it is, by the design items, whether it is a cornered or rounded or squared, there are a lot of features we can notice. So we scatter into the classify the things based on the features. So the same we can do it for the machine learning. Now the question is about the real challenge comes if your data, now it is here, it's a real line. Now some feature, I'm not talking about material property, some features are coded this one, and now this one is the second object. I mean, the same, but the data is represented this one. The blue ones are the type 1 material, or red ones are the type 2 material, let's assume. Now tell me, could you able to give a clear distinction so that you can say this one is this material? If I give you some 11th material now, you have again you find the weight. These are weights, of course. This data is the weights. Now, if I give the 11th material, 11th item, and you find the weight, and could you able to say, suppose if that weight comes somewhere here, let's say here, in between here, could you say that this 11th is the type of material 1 or type of material 2?
No, sir, it's difficult
It's
for distinct.
difficult. Yeah,
Yes, sir.
you don't have there is uncertainty here. You can't say blatantly like earlier case. Now, what you need this kind of thing? What is the next approach?
I think with probability, sir, like
Even probability also, no, it cannot justify. Probability gives the like I understand, like probability as you mentioned, like it may have the highest probability as it is extreme to it, and it may have the least probability, and these may have the mixed probability in around 0.5. So you are coming up like keeping tiled and keeping them as uncertainty. I'm not talking about uncertainties right now. I want a clear distinctions, but it cannot do it here. But how do we do now?
I don't know, sir.
Yeah, now see, this is we do in naturally. What we do, suppose if somebody gave you a mobile and ask you to whether it is a fake mobile or the original of the particular company, then what you do is you have trained for a particular feature, and that is also matching. What you do, you go for the another feature, whether that feature is matching or not. That is also matching. You go for the another feature whether that is also matching or not. So you pick up the features and checking up with trade off between the different features, and at least one or two are differ clearly, then you can say it is a fake. If you can't able to distinguish with a one feature, that means that you are in the situation of this one, right? You can't able to separate it out from the original to the fake one. Now, what you should go in this case, you should go for the next feature. So if you go for the next feature, then what you do, how the graph will come now? Now it is a graph of 2 dimension. Let's say I don't mention what kind of feature it is. In general, I will write up a feature 1 and feature 2. Now, let's say there it is also having metric, feature 1 and feature 2. You can think of like feature 1 is the weight and feature 2 is the height or width or the length or whatever. It depends on the context, but in general, feature 1 and feature 2. Now, if you take feature 1 as this one, and feature 1 you only take and it is producing this one, but when you do the with feature 2, when you do the feature 2, it may come up. I'm not saying it did definitely come up. It may come up like the blue points may fall here because of feature 2 is making this way, and feature 1 is sorry, what am I doing? Yeah, okay. The blue points, blue points, blue data points are the this is the coordinate pair now. Let's say first one is the same point which is having here, and the second one is the second feature weight, second feature what do you say metric. Now it is giving this one. Now uh, the red points may come up here. The red 5 points. See, now you can see that feature 1. Okay, I just wanted to make it much sensible to the above diagram, so that let's assume that these are the feature ones. All these are feature ones, and now we added another feature, that is feature 2. Now if I plot this one as it is, then on the feature 1 scale, they add up here something like mm, let's say this one is the blue point, and this one is the blue point, maybe this one is the blue point, and this one is the blue point, like this I can say. So who is deciding this way and who is deciding this way? This one is decided by F1, this one is decided by F2, right? So my F1, F2 is deciding the upward direction, F2, and F1 is deciding this one. Already you have the this one. This one is you corresponding to this one. Like this one is corresponding to this one is corresponding to this one is corresponding to this one, and the next fourth one is somewhere here. That is corresponding to this one. Now that means that if you project these ones here and you are seeing at the same place here, that is F1. But they are scattered up and down. They are scattered up and down because of what? Because of the F2. F2 is moved them up and some of them down, due to the F2 is behaving the way. And but if you take F1s or the projections, and you get the same blue points here. Now if you do the same thing for the red points, then there is a red point here in the projection, but F2 took it away very long above, and there is another one more red point here that is also kept it here, and there is a one more red point that is sitting here, and there are five such red points. They come up like this. So now if you take the projections like this, all the projections, then you can see the same plot on the F1 because of F1 features are satisfying this one exactly. But F2, now you can think of it like, um, now you can think of there is a, now you can you separate the data?
Yes,
Can you
sir.
separate?
Yes, sir. Yes, I understood. Like if
Yeah.
F2 not helping, then we can increase one more feature,
Yeah,
F3.
exactly.
Yes, sir. Yes, sir. Yes,
Yeah,
sir.
that the way we do it, the way we separate it out, the things usually by identifying the features. Naturally, we do it. If both are matching and go for the next one, if the third is matching, go for the next fourth one. So if none of them are features, whatever the features, yeah, so we can say like, okay, all these are matching, so that it comes to the this category, and so like now you
Sir,
have a clear
I
line. Yeah,
Sir, I have a doubt, sir.
yeah.
Like if we have one data set, like
Mm,
for classification, sir, like our response variable has a classification type, sir.
yeah.
Like let's say we have 10 features for
Okay.
that data set, sir. Then
Mm,
if
mm,
we take the relationship for
mm,
each one with each one, then
mm.
we have a we can't imagine, like we can't
Yeah,
draw
yeah,
the graph because
yeah,
it's
yeah,
10
yeah.
dimensional,
Higher
sir.
dimension. Yeah, of course. Yeah.
Yes, sir. So
Mm,
then, sir, like,
mm.
can we plot this kind of graph using any kind of library? Like, if I want to know which one feature, like if I want to separate the different classes of that response
Mm,
variable, so can we do
mm.
sir like that?
So
Like,
yeah, actually I understand. We have at most three-dimensional graphs we can do. At most at any time three features only you can graph it with the plane separation. Right? It is a 2D feature one and feature two, so that it is a line separation. If you go for the 3D, you will be having a plane separation. Plane separates them, right? So now at a time you can do three features, but not with, suppose you, as you said, like there are 10 features, all the 10 features we cannot graph them. So um, now I'm not touching that part of area. That is a subject of different thing actually, but I will give you different view. There is something called um, what do you call this one, variance. You might have heard variance in the statistics.
yes,
Um,
sir.
and there is another one more concept called dominant direction, or dominant eigenvalues, or the singular values, which being these are the two powerful mathematical tools, variance and singular value decomposition. These two tools are used to find out the which feature really separating it out. Okay, that is the
Okay, sir.
subject of different thing that is not comes into the
Okay, sir.
line of a neural network. That
Okay,
is
sir.
actual machine learning and statistical learning. If we have that subject or sometime, maybe I can discuss them. That is actually a very good question you asked, but that is not being looked at this one. So the highest variance in the data, highest variance feature in the data, which gives the highest eigenvalue. Okay.
Okay,
uh,
okay, sir.
yeah, at this moment, yeah, what I'm saying, it may not be make sense all of you why eigenvalue coming into this one, why eigenvectors are doing the data separation. But the, as you already know, linear algebra and the EVD and SVD, singular value decompositions, maybe we will look at that part, not in the neural network line, and maybe in future or somewhere we meet another platform, we can discuss that. Okay.
Okay, sir. Thank you,
Yeah.
sir.
Yeah. Now my question is this one. Okay. Coming to this subject. Uh, yeah. Now tell me. Now tell me the neural network which does this job. Design a neural network which does this job. Okay, let me first this one. Okay, then this one. This is the problem one, and this is the problem two. The problem one is one feature one, and problem two is two feature one, which does problem one and problem two. And my fundamental question is not just the neural network. How many, I can say, I can ask how many minimum least neurons, I could say. I don't want to expense my network. Minimum neurons are required to solve these problems, solve P1 and P2. Yeah. Now tell me, you take a little amount of time, 5 to 10 minutes, and think of it. How can you architect a neural network so that this job one and problem one and problem two can be done? I will back in 5 minutes. I am looking for answers from you for these two questions.
Sir, for problem one, uh, let's take we give one input x1 and with one bias in hidden layer, only one hidden neuron. I guess like I'm thinking put using a activation function at place of activation function, we will use sigmoid function. After that, calculating like a sigmoid function, what's value come, we can decide like some bound condition, like if a value is greater than 0.5, then we will l- decide this class. Yeah, less than, then we will decide this class. Based on that, we can separate for problem one, and same way, so like for problem two, take one input and with one bias, and but in hidden neurons there are two the hidden neurons with different weights. After that, output is also two with different weights. Same condition also we can apply, sir.
Okay. Do we really need a sigmoid or do we really need a activation function?
Uh, I am
Right?
not sure. I am not sure about that, sir. Like I
Okay.
am thinking
Okay.
this. Just
Okay. So now you can. Anybody else? Any other? Like anybody thinking? Do we really need an activation function?
I think it may works without activation also using different weights. Maybe weights
Yeah.
here playing major roles, sir. With
Yeah.
what like which weights we are choosing if we consider different weights maybe. So I'm not sure. Just I thought
Yeah.
then I.
Yeah, now I am defining something from your inputs without anything like let's say on single neuron, you have only single input like in the problem one case. Let's say this is a simply x1. Now we are getting an output from this. Now what we are in the problem one is if our two types of materials are completely distinct and we are having a kind of a barrier, and below this barrier is the material one, below above this barrier is material two. That is what we are deciding. So now clearly this is, who is this barrier? This barrier is literally the bias. You can think of it like, now why I'm saying this is a let's say okay, this is the x1 we are passing and there is a w1 weight, and this is the your bias, let's say b1. Now you have x1 w1 the weights, and uh, x1 w1. Okay. uh, Now what you have here is something different. X1 w1 plus b1 you write up, right? Then uh, now you we usually apply kind of a activation function on top of this linear combination. Then we now I don't want to apply any linear what activation function. I just wanted to see whether this amount is positive or negative. That is sufficient, right? Let's say
Yes,
I could say let's say your x1 w1 plus b1 equal to 0. That means your data point, whatever you gave it, that is sitting on the boundary. I could say like let's say if x1 w1 is, x1 is the input, right? X1 is the input you are passing the weight, and this is the network weight. If it is greater than this b, then it is falling this way. It is falling in this category. If for w of x, the weight is above this. This is the b. If this is the b, if our w1 x1 is falling this one, then it is a in this category. Otherwise, if it is below, then if it is in this category, that is how the barrier, the bias is actually deciding the boundary of the bias is it is deciding. Now how do you express this one? If now you can write up something like x1 w1 greater than b. If this is true, then you are returning a signal 1. That means you are categorizing the two things into the 2 points like either 1 or 0. And if it is not, then it will return 0. Either of the thing will come. It won't come both. Okay, that I will keep it like kind of in a dashed line. so that either of the thing will come up. If it is satisfying, 1 will come up. If it is not satisfying, 0 will come up. If it is 1 comes up, then you are calling this as a material 1. And if 0 comes up, you are calling this as a material, sorry, if 1 comes up, material 2, and 0 comes up, it is a material 1. So based on that, you think it does the job like single neuron. It is a kind of like, now you need to think of it what B1 and what W1 you should choose, so that it is doing it for all the it generalizes for any data you give it. So who decides W1 and B1? W1 and B1 are decided by the data. How data is apart from this, how data is sitting, the weights of the materials or the weights of the products which used, that decides where should be this be, and where should be the generalized W1, so that which definitely takes the material twos into this side and material ones into this side. So for this, for different inputs you take up, the different W1 B1s may come up, but we need to come up with a fixed W1 B1 after a certain training that will come up like it decides. So now there is no sigmoid, there is no nothing. It is just a simple inequation is doing the job. Okay, W1 X1. Now it is sufficient. So now, if for the clear data of one input, now apply for the same problem with the same thing. Single neuron is sufficient, as you see right now. Now, for the this one, does it x1, x2, w1, w2, and you have a bias, let's say b1 with 1. So now it is x1 plus sorry, x1 w1 plus x2 w2 if it is greater than b. I am writing b1. Okay, let me erase the b1. Oh, we are using only one b. Then what is this? This is a line equation, right? Inequation. It is in the form of what? It is in the form of ax plus by line equation. If it is greater than some constant k, then it is giving this part. If it is less than, it is giving below, and if it is equal, then this is this one. You know linear programming already. I don't need to explain linear programming. Am I know? You know the linear programming, right?
Yes, sir. Yes, sir. Yes, sir.
The regions are separated by the inequations. What I mean. So now one decision is sufficient whether my ax plus by, in this case not ax plus by, in this case features, if I write here like uh, uh, here I wrote something f1 f2, but we are using what, yeah, in this case x1 w1 plus x2 w2, x1 w1 plus x2 w2. So that is here x1 w1 plus x2 w2. If it is above, if we can able to find out a k such that this line can be clearly distinct between the two regions, then I am done, right? The k is nothing but here in this case bias, the b. So now my thing is I need to figure out what w1, what w2, what b I should provide, so that I will get a this line. So that's it. So how many neurons is required? Simply again one neuron.
Yes, yes, understood, sir. Yes, sir.
Simply one neuron. Based on that, now you can decide whether it is either 0 or 1. 0 is you can take up whatever, like 1 is for the above and 0 is for the below, that is greater than b, then 1, and below then 0. Say single neuron is sufficient, no, nothing. Now, what W1, W2, WB is providing, they are actually representing a line equation, the line which separates the two data. So now you train the network and gather the W1 and W2B. Let's do an experiment. Like take your graph paper or something. You choose some 20 points here and choose some other 20 points or around 10-15 points here. And now you know already classified, you classify them as category 1 and this is a category 2, and you label them with the category 1, category 2. You train them. Once you train with this network, write a small Python program, train this with the, you choose your own data. By knowing that, you know already they are separated with the two features, and give them labels as category A or category B, or 1 or 0. For this one you can, yeah, this is better, you keep it them as a 1 or keep it them as a 0, and you train up several times. Then you will come up with the finally W1 W2B. And now what you do, use this W1 W2B to draw a line. Now look at the line. You draw a line equation from the network output. From the after training you will get these three parameters. They settle down, and definitely the line equation goes this one. The line equation definitely separates it out. Now if you give any new x1 x2 new data, immediately if it is a new data from this region, it will act accordingly. It will immediately, it will give a class 2. And if you give some data from this region, it will definitely give the class 1, because now it is separated by a line equation. Okay, a simple single neuron can do the classification of this type. Okay, now I am moving something big, something you can do it. Do the experiment. Do kind of like take a simple Python program. You write up like simple Python program and try to take a two classes of distinct data, and then now take for same thing for 2D case, and you think of the decision boundaries, how they are representing the decision boundaries by the parameters. The parameters actually drawing virtually a line equation or a plane equation. If you are a next level 3 features, if you take up a plane equation, you will come up. If you take 4 features, then you will come up with hyperplane which separates the features of the two categories. Okay, now what I go with the next case, you think on it. Yeah, let me put it this way. uh, Now my data is of not in the feature like real number quantifying. My data is a kind of like answering questions. There are questions are answered, several questions are answered. All the questions are true or false. All the questions are true or false. There are two questions were asked. Let's say question 1 and question 2. And the outputs are gathered from the people, whatever they say. This is true, they said, and this is false, they said. Many people, or this may be true, this is also they said true. It may come up, this is false, this is true, and they said like this is false, this is false. So there are, if there are two yes or no questions or true or false questions, these are the only possible outcomes from the people we can gather, right? This is my data collected from the survey. This may be having a lot of hundreds of data, but finally if we bring it down to short version, and only these are the core outcomes. Now I just wanted to draw a neural network, where uh, but the actual answers, maybe these are the answers for the actual um, for the product. These are the actual answer, should be actual answer for not the question 1, question 2, cumulative answer. I mean the satisfiable reasonable answer from the function of question 1 and question 2 should be, this is must be a false, it must be true, it must be false, it must be uh, false. Okay, then now make a neural network which produces this one. That means like I need a neural network. You are passing something, two things, either true or false, either true or false here, either true, 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 false, 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 true. And now we are expecting accordingly this one. This should satisfy this one. Okay. So that means like if you pass the true and false, it should give the false. If you pass the true and true, it should give the true. If you pass false and true, it should give false. If you pass false and false, it should give the false. Now, what should be here? You understand my question? It's simply, I think, what gate it is, AND gate or gate. It is AND gate. You know, gate.
And get
It's in AND or AND, I guess.
And gate, sir. And
AND
gate.
gate. Yeah, it is AND gate. So how do you construct that?
we will mark true as 1 and false as
Okay.
0. If
Okay.
this one is 2, we can put this. If it's 1, we can
Okay. Now my question is, what they represent, weights and bias on this one. These are all there, right? How do we train this W1, W2B such that they do the job? So that is, of course, we have to give it something here so that they will give the things, right? So as you said, like this is, let me keep it as it is. Um, so now if you send inputs as like 1 or 0 or 1 or 0, and output I'm expecting 1 or 0 according to the AND gate. How do you build this question mark? Is it possible with single neuron, first of all? You can think of like I'm just giving the same, I have just explained the same, but in a different context. You can think of this as a 0, this as a 1, and this as a 1. There are two features like here, this one and this one, same as we have done here, x1, x2. But here x1, x2 are the numbers of real numbers, any kind. But here our domain is just a boolean, 0, 1. We can't accept anything else. So now again you can see, just making it 0, 0 is 0, that is red mark. 0, 0, false, false is false. Uh, Another one is true, false. True, false. This is a true, false. You can say, you can think of like this is a kind of 0, 0. This is 0, 1. I'm sorry, it's 1, 0. This is 0, 1, and this one is 1, 1. Now you mark it. 0, 0 is a false, 1, 0 is a false, and 0 comma 1 is a false, but uh, 1 comma 1 is true. Now if you train this network, W1 W2 B will give a line equation which comes just like this. There are two regions. This must be W1 plus W2, W1 plus W2 greater than B, or it is equal to B, but above is greater than B and below is less than B. Okay, here the 1 and zeros are may playing the role. So the
Sir,
possible scenarios like W1 greater than B if W2 is 0, I mean input is 0, or W2 is greater than B, or W1 both are ones, then W1 plus W2 greater than B. So the linear program which is satisfying these three conditions will give you a this one, the line equation. Yeah, really.
sir,
Yeah, of course. Yeah, you can go with the Relu as well. Relu also does the job because of it has its own feature of it. But now I don't want to use any activation function. I'm
sir,
not using any activation function. I'm just using a just a identity. The target is the our activation function is identity function. We are not applying any composition there. I think I gave this question in the Relu concept or no in the as in the exam. Constructing and gate in the did I give you and gate through the relu? No,
no, sir.
no.
Sir,
Okay,
if
okay.
we
I
fix
thought I gave you.
W1, if we fix
Hmm,
W1 equal to 1 and W2 equal to -1 and
hmm.
B equal to 0, then I think
Yeah,
it
that
will work.
that will come up. Okay, that I'm
Yes,
saying
sir.
that of course those things will fix up by the solving the problem. Okay, so now my question is about like this gate you can build it very easily. Now the real problem comes with another gate, that is OR gate is also comes very simply. OR gate is also you can make it up good way. And now XOR gate. XOR gate is like you have true true it is a false, and false true is a true, true false is a true, and false false is am I correct? I think I'm wrong. I forget actually.
False false is
False.
false, I guess. Sir.
Yeah, false
At-
false 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 is false and true true is false. Okay. Yeah,
Yes,
correct.
sir.
Yeah, yeah, this is correct. Yeah. Now, if you think of in the same way, to find out a neural network, now you really struggles. Why struggle comes here, right? If you take the same sense 0 1, okay, let me write up 0 comma 0 1 comma 0 uh, 0 comma 1 and 1 comma 1. Okay, correlate with the true with 1 and false with 0. Now think of it, what's happening now. You can see that the okay, the real outcome I am keeping false as a red color. So false false is this one, true true is this one, and now false true is this one, true false is this one. Now tell me what neural network, what neural network will give this one? Can you separate it out?
Uh, it is difficult, sir, for separating using a linear line.
Yeah, insignificant. But of course, there is a solution to it. And now it is a real stress point how neural networks to deal with this one. This is a powerful tool by the neural network. We cannot imagine, but neural network does this one. But now think of it. Now we need single neuron can't do this task. Think of it. We need multiple neurons. Okay, I will give the hint, but you should construct a neural network. I will give this one. Now I need the domain separation, not just with a single line and with multiple lines. So now this entire region should be true region, and the entire region outside this one is false region. This one. So now, no matter whatever you give this one, it will come up like this. So you need the linear programming. If you have the line equation of this one, you have line equation of this one. You know how to look at the region between the two lines. You know it, right? Region between two lines. One is
So yes,
less
sir.
than, one is greater than, and other one is above, and other one is below of this one. We can separate it out, the three regions,
Yes, sir.
right?
We can do. Yes, sir.
So yeah, now what neural network you should build such that it does this job. Okay, not just for XOR. Suppose your data is also like this. I have just given for the XOR information. XOR is actually behaving this way. Even in our real life, your category of data is falling in this. Like earlier, we have started this one very second problem. The category of this one is this one. This one is this one. But again, you see like some other blue dots are here. Then you should know that if you should separate this region into the three parts if the prediction or if the new data which you are looking whether it is falling this region or this region or this region, based on that you can categorize, right? If the red dots are sandwiched between the blue dot groups, either blue dots have two groups, like one group is sitting here, another group is sitting here, but the red dots are sitting in between. Then you can also classify them based on the which group it is falling. It not just sitting with the just for the XOR. It is also applies here if such a type of data is with you. Now, I don't just ask you for just simply you try the construction of the neural network in this one and apply the same example. Write a Python program by taking different three. I think I have given ask you to develop this problem two for finding it out, w1 w2b, to find out this line. Now find out the same thing for the three different data groups you take up, and you should know before trying the procedure, you should know the what is the neural network which producing this XOR. The same you apply for the problem too for three groups of two category items. Then you will be experiencing really the decision making power of neural networks. Okay, tomorrow, next class, we will see much more complicated versions of these things, how neural network can be built out of those complex parameters, and that will give a kind of, a good feel of powerful, the powerful classifier of neural network. Now, instead of so far, we have seen the converging of neural networks and dense, all those things. Now we are slowly looking at in the data perception, and especially in the classification of regions by the neural network. Now you have two exercise with you. I would suggest, like, you are not doing it. You submit me these are exercise yeah, as an assignment that will take up into your evaluation. Um, in this one, first exercise one is a kind of, no, this one, very beginning I gave you, yeah, this one, the differentiation of this one. This is the exercise one. You do it. Um, the differentiation of just simply that differentiation and bring that. Even of course, I will explain in a different way, but you try them before. And the exercise two is you write a program for classifying the neural network for different groups, and you synthesize, take the data synthetically, and assuming that they are classified properly with different two groups. And this one, problem two, and now this one, construct a neural network for XOR which separate the two regions, and use that neural network, same neural network, to separate the problem 2 if problem 2 has its three different groups of two types of data. I think I gave enough details for your exercise. Okay.
Yes.
I will.
Okay,
Yeah,
sir.
I
Tomorrow we
will.
will have class, sir.
Tomorrow, I will inform you by today evening. Okay.
Actually, sir, tomorrow at after tomorrow we have exam, sir. Tomorrow we have two classes, sir, from 9 to 11,
Okay.
sir.
Okay.
Uh, uh, yes, sir, 9 to 11 we have classes. After that, sir, we are free, but after Friday we have exams, sir.
Okay,
So,
okay. Then this week, do you have any free time? So that next week I will be not taking, as I said already. Uh,
this week,
Anytime, I don't have any problem.
Saturday, sir.
Yeah, I am okay. Saturday.
Sir, I have to ask others also.
Yeah, yeah.
Schedule is
You
there.
find out. Yeah, you
Okay,
find
sir.
out Saturday, Sunday, no problem.
Okay,
Uh,
sir.
yeah, even on Friday after our exam, I don't know your timings, but even I don't
Timings
have.
are 1:30 to 3:30, sir. Exam.
Okay, okay. Yeah, I don't think you are be attending after that. You are maybe exhausted. Okay. You decide and tell me. Okay.
Okay, sir. Okay, sir. I will
Oh,
inform you. Okay.
yeah.
Okay, sir.
Sure. Thank you. Bye.
Okay. Thank you, sir.